All right, let's get into it. We're going to talk about something huge, literally, that we rely on every single day without even thinking about it, our bridges. And today, we're looking at how a brand new high-tech crew of robots is completely changing how we keep them safe.
I mean, really think about that for a second. We see the big steel beams, the concrete on top, but a bridge's true health, a lot of that is hidden from view. We're talking about tiny cracks, corrosion on the inside, or this thing called subsurface delamination, which is just a fancy way of saying the layers of concrete are separating where nobody can see them. And those are the kinds of hidden issues that can become massive problems down the line. So the big question is, how do you find a problem before it becomes a disaster?
You know the scene. We've all been stuck in it. The flashing lights, the sea of orange cones, traffic crawling along in one single lane. A lot of the time, that whole mess is for a bridge inspection. Now, it's a super important job, obviously, but the way we've been doing it for decades, it comes with some serious drawbacks, not just for our commute, but for safety and the economy.
And this is where things get really interesting, this jump from the old way to the new way. In one corner, you've got the classic manual inspection. That's your traffic jams, that's putting people in some pretty risky spots, and honestly, it relies on data that can be kind of subjective. But in the other corner, you have this new robotic approach, and it is a total game changer.
Yeah, the old way often involves these giant vehicles they call snooper trucks. They have these huge articulated arms that have to reach way under the bridge. And to use one, you guessed it, you got to shut down traffic. It's incredibly slow, it's expensive. I mean, think about the cost of all that traffic control. And, it puts inspectors right in harm's way, dangling over traffic or water just to try and get a good look.
So if that's the old way, what's the alternative? Well, it's not just one single robot, it's a whole coordinated team. So let's meet the crew that's making inspections faster, safer, and a whole lot smarter. This is where it gets really, really cool.
Every mission needs a command center. For this team, it's basically mission control on wheels. A van that's just jam-packed with all the drones, the crawlers, and the computers they need to run the whole show right there at the bridge site. No giant, lean-closing trucks needed.
First up, you've got the Scout. This is an Helios drone, and its big trick is that protective cage around it. It's designed to be collision-tolerant, which means it can literally bounce off of things without crashing. This lets it fly deep into those tight, complicated girder systems under a bridge, places that are just way too difficult or dangerous for a person to get to.
Then you bring in the heavy lifter, the DJI M600. So while the Scout is all about being nimble, this drone is all about pure power. It's built to carry much heavier equipment, which means you can load it up with multiple really advanced sensors all at once, things like LiDAR scanners and thermal cameras, to get a whole bunch of different kinds of data in just one flight. This is the real workhorse of the team.
And last but not least, you've got the specialists. Check these out. They're small magnetic crawlers. So after the drones have done their flyby and maybe spotted an area of concern on a steel beam, you can send these little guys in. They actually crawl right on the surface, getting super up close and personal to take incredibly precise measurements. It's amazing, right?
Okay, but here's something that's absolutely crucial to understand. The robots themselves are really only half the story. The real revolution here is in what they can see. They're carrying sensors that give them these technological super senses, letting them see a bridge's secrets in ways the human eye just can't. Take a look at this. On the left, that's just a normal photo of a bridge deck. Looks pretty normal, right? But now look at the image on the right. That's a thermal image. Those different colors show temperature, and those warmer spots, they can be a sign of that hidden damage we were talking about, the delamination. It's kind of like taking the bridge's temperature to find a fever that you would have never seen otherwise.
And this just shows another incredible leap. So a normal photo gives you a flat view, but by using LiDAR, which is basically just bouncing lasers off of everything, the drones create what's called a point cloud. It's a super precise 3D map made of millions and millions of data points. What you get is a digital twin, a perfect digital copy of the bridge that lets engineers measure any single part of it right from their computer.
So this all sounds fantastic in theory, right? But how does it actually perform out in the messy, real world? Well, to find out, this whole system was put through a massive coast-to-coast stress test.
And believe me, this was no small trial. A huge pooled fund study sent these robotic systems out to bridges in 7 different states, which covered a massive range of climates, weather conditions, and bridge types. The whole point was to prove this technology could handle whatever you threw at it. And the scale of this thing was just enormous. They inspected 59 different bridges. That's 59 unique structures. We're talking old ones, new ones, steel bridges, concrete bridges, each with its own history and its own problems. The goal here was to build a giant set of data to prove, without a doubt, that this system can work anywhere, on any bridge.
And yep, they found real issues. Take this bridge in Virginia, for example. The drones were able to fly right up close to those steel girders and spot specific areas of corrosion right near the supports. I mean, these are exactly the kinds of details that are really tough to see from a distance but are so important for maintenance crews to catch early on.
And that brings us to what might just be the single most important part of this whole revolution: how it fundamentally changes the inspection report itself. We are moving away from descriptions and words and into the world of pure, objective data.
I mean, listen to this quote. It's pulled right from the research paper describing the old way of doing things. What does moderate corrosion even mean? Is my moderate the same as your moderate? How fine is a fine crack? This language is just totally subjective, and that wiggle room can be a real problem when you're talking about the safety of our infrastructure.
And here's the difference in a nutshell. On the left, you've got the old way, inspectors on the ground, just looking up and making notes. But on the right, you see the new report. Using AI and those super high-res images from the robots, the system can automatically measure the exact size of a rust spot, down to the millimeter. There's no more guessing. Subjectivity is out, objective, provable data is in.
So the technology is obviously impressive. There's no doubt about it. But what does all of this really mean for us? You know, for the people who are just driving over these bridges every single day.
Well, let's just quickly sum it all up. First, it's way safer for the inspectors. For us, it's faster, which means fewer traffic jams. The data they get is so much better, seeing stuff both on the surface and underneath it. It creates that digital twin so we can track a bridge's health over its entire lifetime. And, maybe most important of all, it turns inspections from a subjective guess into an objective science. And that means we can fix small problems before they become giant, multi-million-dollar headaches. When you step back, you realize this tech isn't really just about bridges. It's a peek into the future. So what happens when we start applying this mix of robots, AI, and big data to our entire infrastructure?
It means we're heading towards a future where our infrastructure is just smarter, it's more resilient, and ultimately it's a whole lot safer. It means that the next time you drive across a bridge, you can feel that much more confident in your journey because there's an unseen crew of robotic inspectors working tirelessly behind the scenes to find the smallest of problems long before they ever get the chance to become big ones.